Hello scholars, and welcome to this video lesson on the real number system. We're going to be talking about rational versus irrational numbers, and by the time we're done with this video, I hope that you're able to define what a rational number is, what an irrational number is, and give me good examples of each. What I need you to do to start this lesson is you've got a little bit of cutting and folding to do. So where it says cut, I mean, if you're careful on here and can follow directions, you should be able to do this no problem. We're cutting out this little rectangle up here. We're cutting out this little rectangle over here. And down here, you need to cut along the dotted line. You need to cut this dotted line too, but don't cut the solid line. The solid line needs to stay. Okay, cut along here, cut along here, cut along here, and here, and here. You need to cut in here, and you need to cut over here. Save this little box right here of numbers. We'll be using that in a second, and you should end up with something that looks like this. Ooh, yeah, okay. Go ahead and pause the video and get to where I am at with this cutting phenomenon. You all see what you need to cut out. Be very careful. Let's not have to do it more than one time, 8th graders. Well, welcome back. I've got this, and I've got this little card with some numbers on it. Let's go ahead and fold this together real quick, shall we? What I want you to do first is you're going to take this little thing, and we are going to fold it up where it says fold here. Then we're going to take these little friends, and we are going to fold them in so we see the word whole number. And we see the word natural number. Yes. Should look something like that. Doesn't have to be perfect. Now, I didn't print the back to this because it was not printing well. So I need you to go ahead and add the word integer right there. Integer right there. And then we're going to make little doors here. Make little doors. We're going to fold these in. They basically come in to the header part of this, yeah? To where this will line up right here nice and beautiful. We're going to make a door right there. On this first door on the left-hand side, we're going to write nice and big rational numbers. On the other door, we're going to fold it in, and we are going to write irrational numbers. Rational and irrational numbers. You have now finally completed the real number system. You didn't know until today that you hadn't learned all of the numbers that were contained in the real number system. This means all the numbers that live on the number line, okay? But I am about to help you complete that story and learn the entirety of the real number system. It's very exciting. I hope you're as excited as I am. Okay, so we're going to open this thing up, and we are going to add some information on the inside. Okay. Now, let's first define what a rational number is, okay? A rational number, a number is rational if it can be written. If it can be written as a ratio. Oh, there's that word, rational ratio. Do you see it? Like it's in here. Rational ratio. Okay. If it can be written as a ratio of 2, that's an F, I promise, of 2 I'm going to say integers, because I want to be really specific, of two numbers. You know what this means? This is a really complicated way of saying that it can be written as a fraction, a ratio, a fraction, okay? It can be written as a ratio of two integers, or we could just say it can be written as a fraction. This includes terminating, oh, I'm about to spell that wrong. Terminating and repeating decimals. This includes terminating and repeating decimals. Guess what? That's because we can write terminating and repeating decimals as fractions. Okay? So basically, everything on this side, in some way or another, I can write as a fraction. You know, I can write the number, 2 as a fraction, right? 2 over 1, right? I can write the number -5 as a fraction. That's just -5 over 1. Anything that is a rational number can in some way be written as a fraction. I think that's the best way to define a rational number, okay? But all these things over here are rational numbers, okay? It includes fractions, repeating and terminating decimals, natural numbers, whole numbers, integers. We're just getting more and more specific in the land of rational. In kindergarten, you learned what a natural number is. Those are your counting numbers, right? Let's write the word counting numbers. For instance, on our little sheet right here, I see 8 is a counting number, 3 is a counting number. Those are rational numbers. 3 is a counting number. 8 is a counting number. 100 is also on here. That's a counting number. Okay? In kindergarten, you learned these numbers. You didn't know that they were rational numbers, but they are, because you've always learned rational numbers. And then later, you learned whole numbers. The word whole numbers is really similar, but it includes the number 0. You eventually learned that 0 is a number. That's the same as saying natural numbers. It just also includes that number. Ooh, then you got later into elementary school and into middle school, and you learned the word integer. Those are positive and negative whole numbers. Positive and negative whole numbers. Oh, let's look at our sheet, okay? Well, this would be a whole number, except it is negative. Except it is negative here. So what else? Oh, -12. That would be a whole number, except it's negative. Oh, -50. Okay, let's write all of those down. So we said we've got -3. We've got -12. We've got -50. Those are all integers. Those are all positive and negative whole numbers. But guess what? Natural numbers, those are integers. Whole numbers, those are integers. And these are all rational numbers. We're just going to add a few more that you know, but you've just never written them or you've never called them rational before, okay? Anything that is a fraction is rational. That includes positive and negative, okay? So I'm going to write 1/2. I see that on here. I'm going to grab all these other fractions. Negative 1/4 is a fraction. That's rational. A 3/4. I see that on our list. That is rational. I know that terminating and repeating decimals are rational. So any decimal that stops, it doesn't continue on. For instance, 4.25 is rational. 1.5 is rational. What else do we have? We've got negative 0.125. That is rational. It stops. It doesn't continue on. We've got 9.875. That stops. That is a terminating decimal. I can write that as a fraction, right? 9 and 875 thousandths, right? Okay. What else do we have on here? We've got repeating decimals. I see 0.3333333. I'm going to write it with one of these fancy lines on it that shows that that 3 is repeating on and on. That's just the fraction 1/3, my friends, okay? So, again, we've got anything that's terminating or repeating can be written as a fraction, so we know that that is rational. Am I missing anything on here? I don't want to miss anything. I think that's all. I also want you to know, like, I'm going to throw in an additional example, like anything that is written as a perfect square, like the square root of 25, you know, that's technically a whole number because that is equal to the number of 5, okay? So perfect squares are also rational. Okay. So those are irrational numbers, but we also have irrational numbers. You know some of them already, okay? You know some of them already. I just want to put them on the real number system for you and help us distinguish between what's rational and irrational here. Okay, let's write a kind of a definition here first. A number is rational if it cannot be written as a ratio of 2 integers. Well, that's a pretty easy definition, right? Something's rational if it can be written as a ratio of 2 integers. Something is irrational if it cannot be written as a ratio of 2 integers, if it cannot be written as a fraction. Okay? This includes non-terminating and non-repeating decimals. Another really good example of irrational numbers that we're going to see a lot are imperfect squares. Okay, so there's only 3 numbers left on this sheet. I think pi should be obvious, right? Pi is 3.14, blah, 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 blah. It doesn't stop. It doesn't repeat. Its decimal goes on forever without doing those 2 things. Therefore, it is an irrational number. It is one of our best examples of an irrational number. Another number we have on here is the square root of 2. You can just ask yourself what number times itself gives you that number. If you can't come up with one, then it's irrational. That's the simplest way we can write this number. The square root of 25 over here I know is 5 because 5 times 5 is 25. So the distinction for you should be pretty clear. Another example on here is negative square root of 7. Again, I don't really care about the negative sign here. Whatever. Negatives can be rational or irrational. The thing that makes this irrational is the fact that there's no number times itself that equals 7. Don't say 7 times 1 because that's not the same number. It has to be the same number. It has to be 5 times 5, right? So that is irrational number as well. Another example we like to throw out there is just like anything that like any decimal that is like random that just has this ... to it, okay? Now, obviously, they wrote this as 0.3333 with a ... The thing you should notice here is that this 3 is repeating. It's continuing forever and ever, which makes it rational. But this doesn't have like a repeating nature to it. Nothing's repeating here, okay? So this is going to be an irrational number, a decimal that does not terminate or repeat. Oh my God, I spelled terminating wrong. Terminating or repeating. Terminating. Okay. Excellent. So that should help you to do this kind of thing. We're going to have an activity that you're going to do here soon, hopefully, that has like splits it up. I want you to be as specific as possible on this one. Obviously, all 4 of these over here are rational, right? A natural number is rational, a whole number is rational, an integer is rational. I just want you to be as specific as possible, okay? The most specific you can get is natural. So if you get a counting number, you're gonna color it natural. If you get 0, the things that equal 0 are going to be whole numbers, etc. Also, make sure on this sheet that you simplify things. For instance, the square root of 16 is 4, so this is -4. I would like you to highlight that as an integer, a negative counting number. So you got a little work to do on these. 70 divided by 7 is 10. That's a whole number, right? So be as specific as possible. Please let me know if you have any questions. I hope this was helpful. Remember, we can close the doors here and we can see the examples of rational numbers and irrational numbers, but you need to know these are all part of the real number system. Thanks.